We present SSVL, a spatially situated visual language for authoring workflows for mobile robots and IoT devices. Through SSVL, we address the challenges of authoring complex HMR workflows in dynamic and spatial environment. We design a spatially situated visual language to enable users to program mobile robots using standard programming constructs in the spatial environment. We implement a web-based editor called Vipo. Vipo is a web application that can run on any modern-day web browser. Users first define functions by making use of programming constructs. To reuse a workflow, users can right-click the desired function. Functions can be expanded to see details of steps that they are comprised of. To make a function more customizable, users can define a parameter and replace any constant number. Then they can pass a new value to the called function. The programs can be tested for correctness and debugged in the test mode. The task planning layer comprises of Vipo for programming workflows. The ROS server constitutes the task control layer. Machinery and robots constitute the task execution layer. A typical workflow comprises of the following steps. The physical setup comprises of an omnidirectional robot capable of autonomous navigation using LiDAR and SLAM, a robotic arm for pick-and-place operations, 6 ESP32 microcontrollers emulating 6 smart machines, Vipo for programming the workflows, the ROS master for task control and execution. Machines communicate with the ROS master in real time using DRDF messages. First, the user programs the workflow using Vipo in edit mode. Next, the program is verified for correctness in the test mode. In deploy mode, Vipo generates a task script that is sent to the ROS master. The ROS master interprets the task script line by line and controls the execution of the program. High-level task script is interpreted and converted to machine executable instructions with the help of custom libraries in the ROS master. In deploy mode, Vipo displays actions and location of the robot in real time. In case of error in the robots or machines, ROS master stops the execution of the task in action and calls for user attention by displaying an error message in Vipo.